October 2nd, Exponent Rules. So for today, rules on how to combine exponents. Exponents are repeated multiplication, right? So is there some kind of way we can combine them? There is. Let's say that x cubed is equal to x times x times x, and that x to the fourth power is equal to x times x times x times x. If we multiply these two together, x cubed and x to the fourth, we can multiply x by itself 7 times. So how did we get 7? Well, we added those two powers together. 3 plus 4 gave us 7. So when you're multiplying two numbers with the same base, or two exponents with the same base, just add the powers. X to the a times x to the b equals x to the a plus b. For some examples, this one becomes x to the 7th. 2 plus 6 is 8. 4 plus a negative 2, or the same thing as 4 minus 2, becomes v squared. This same base, negative 2, if we combine the exponents, it gives us the power of negative 2. 2 to the 6th, because 3 plus 3. U to the negative 13th, as we add those together. So 6 plus 7 is 13, minus 10 is 3. Negative 8 to the negative first. Now, is that possible? Can you have negative exponents? Well, you can. Typically, though, we put them on the bottom of a fraction and we change them to a positive. So, for example, this would be 1 over negative 8 to the first. Or this earlier problem, negative 2 to the negative second power would become 1 over negative 2 squared. This is what we do with the negative exponents. A couple more to go. Our base is 11 for all three of these. Our exponents are positive 2, negative 3, and negative 9. If I add those three numbers together, I get negative 10. And if you remember my rule of what to do with negative exponents, this becomes 1 over 11 to the 10th. So the negative becomes positive, but it moves to the bottom of a fraction. This is x to the 0, as negative 5 minus 4 is negative 9 plus 9 is equal to 0. And anything raised to the 0 power, even if it's an x, is always just going to be 1. What about with fractions? Well, we still add them. So x to the 1/4 times x to the 1/4 becomes x to the 2/4, which can be reduced to x to the 1/2. And we'll learn a little bit later this week, this is the same thing as the second root of x to the 1st, or more commonly expressed as the square root of x. So if we have x to the 1/2 times x to the 1/3, we add these fractions and we might convert them to sixths. So 3 over 6 plus 2 over 6, and our new exponent is 5 over 6. Rule number 2. So if multiplying powers together adds them, then logically, shouldn't doing the opposite, dividing, do the opposite? Yep, I'm impressed. You guys figured it out without even me saying anything. If you have x to the a power divided by x to the b power, then we subtract those two exponents. So for example, x to the 8th divided by x to the 4th, this becomes x to the 8 minus 4, or just x to the 4th. This becomes x to the 3rd minus a negative 4. Those two minuses become plus, and this gives us x to the 7th. Try some of these others. Finally, rule number 3. If we have ways to add powers and ways to subtract powers, shouldn't we have a way to multiply powers? We do. We refer to it as power to a power, or power of a power. Like if we had x squared cubed, notice that's x squared times x squared times x squared, which is the same thing as x squared times 3, or x to the 6th. So here, if we have x cubed raised to the 6th power, this gives us x to the 3 times 6, or just x to the 18th. Similar situation here, x to the 7 times 2, or x to the 14th. Try a few of these other ones on your own.